Welcome back. This is our 7th midterm prep video. Today we have two microwave links and we want to figure out which one will actually work. Here is the setup. LINK-1 operates at 10 GHz over a 1-mile distance. LINK-2 operates at 1 GHz, but its distance is unknown. We have to find it. Both links use the same antennas with 20 dBi gain at each end, and the same cabling with 2 decibels of loss at each end. We have 5 parts to solve. Part A. Find the distance of link 2 such that its free space loss equals link 1's. Part B. If link 1's transmitter outputs 10.6 dBm, find the link 1 RSL. Part C. If link 2's RSL is negative 72.6 dBm, find link 2's required transmit power. Part D. Receiver thresholds are negative 90 dBm for link 1 and negative 60 dBm for link 2. Which link can operate? Part E. For the failing link, what can we do to make it work? Quick dB recap before we dive in. Same as last video. dB is a ratio, 10 log of a power ratio. dBm is absolute power, dB above 1 milliwatt. dBi is antenna gain reference to an isotropic radiator. And the magic that makes link budgets simple. Logarithms turn multiplication into addition. So in the dB world, transmit power, gains and losses just add and subtract. dBm minus dB plus, dBi minus dB plus, dBi minus dB equals dBm. Units always collapse to dBm at the end. Now let us solve. Part A. Find link 2's distance such that both links have the same free space loss. Recall the FSL formula. 96.6 plus 20 log of distance in miles plus 20 log of frequency in gigahertz. For link 1 at 1 mile and 10 gigahertz, 96.6 plus 20 log of 1 plus 20 log of 10 equals 96.6 plus 0 plus 20 equals 116.6 dB. For link 2, we want the same 116.6 dB, but with frequency 1 GHz. 116.6 equals 96.6 plus 20 log d plus 20 log of 1. 20 log of 1 is 0, so 20 log d equals 20, meaning log d equals 1. Therefore, d equals 10 miles. Link 2 reaches 10 miles at 1 GHz with the same loss link 1 has at 1 mile and 10 GHz. Lower frequency lets you go farther for the same loss budget. Part B. Find link 1's received signal level. We use the link budget equation. RSL equals transmit power minus transmit cable loss plus transmit antenna gain minus receive cable loss plus receive antenna gain minus FSL. Plug in link 1's numbers. Transmit power is 10.6 dBm, minus 2 dB cable plus 20 dBi antenna, minus 2 dB cable plus 20 dBi antenna, minus 116.6 dB FSL. Add it all up, 10.6 minus 2 plus 20 minus 2 plus 20 minus 116.6 equals negative 70 dBm. Link 1's RSL is negative 70 dBm at the receiver. Part C. Find link 2's required transmit power, given that its RSL must be negative 72.6 dBm. We rearrange the link budget equation to solve for transmit power. Transmit power equals RSL plus transmit cable loss minus transmit gain plus FSL minus receive gain plus receive cable loss. Plug in negative 72.6 plus 2 minus 20 plus 116.6 minus 20 plus 2. Compute. Negative 72.6 plus 4 equals negative 68.6. Minus 40 equals negative 108.6. Plus 116.6 equals 8 dBm. LINK-2 needs 8 dBm of transmit power to deliver negative 72.6 dBm at the receiver. That is about 6.3 milliwatts. Part 2. Which link can actually operate? The rule is simple. The received signal level must exceed the receiver sensitivity threshold. If RSL is greater than threshold, the link works. If less, it fails. LINK-1. RSL is negative 70 dBm. Threshold is negative 90 dBm. Negative 70 is greater than negative 90, so LINK-1 operates with 20 dB of margin. LINK-2. RSL is negative 72.6 dBm. Threshold is negative 60 dBm. Negative 72.6 is less than negative 60, so LINK-2 cannot operate as designed. The signal is too weak by 12.6 dB. Part E. What can we do to fix LINK-2? We need to either increase RSL or relax the threshold. Since the receiver is fixed, the practical fix is to reduce the link distance. Shorter distance means lower FSL, which directly raises RSL. Cutting the distance from 10 miles down to about 2.5 miles would gain us the missing 12 dB and put the link back in the operating zone. Big picture comparison. Both links share the same FSL of 116.6 dB and the same antennas. LINK-1 delivers an RSL of negative 70 dBm, well above its negative 90 dBm threshold. 20 dB of fade margin, a healthy link. LINK-2 delivers an RSL of negative 72.6 dBm, but its threshold is much higher at negative 60 dBm. It fails by 12.6 dB. 3 takeaways. 1. Equal FSL does not mean equal feasibility. Receiver sensitivity matters as much as transmit budget. 2. A higher receiver threshold is harder to satisfy than a lower one. 3. When a link fails, the cheapest fix is usually distance. Everything else, like bigger antennas or more power, costs more money and more permits. And that wraps up our midterm prep batch. Good luck on your midterm.